Hello students, my name is Sumit. I am a PMR PhD scholar IIT Palakkad. Today we will discuss the week 7 of the live discussion section, in which we will cover lecture 31 to lecture 35 by Professor Ashok Desar IIT Kanpur of the subject Turbulent Combustion Theory and Modeling. In this section mostly we will solve the MCQ problems. All the MCQ problems are taken from this website. Quickly go through the MCQ problems. I think this week and maybe next week also the MCQ problems, which will be a basis for your subsequent lecture. This lecture is more basically important simulation point of view. Okay, how you do modeling. Okay, that's the reason why the problems are mostly cannot problem. For any kind of modeling, stability is the major criteria. So what is stability? The question, stability is defined as dash. Okay. So the answer is very simple. The answer is A. The stability is only possible for what? Iterative solvers. Means if the solver having some iterations. Stability it describes how well equation can be solved using iterative solvers. Okay. So see the next. So next question. Which of the following is used to analyze the stability of a system? Very simple question. Okay. You know, stability when comes into existence means the best formula is von Neumann's stability analysis. Yes, if you gave the course, then you also know this von Neumann's analysis and how we can find out stability using von Neumann's stability analysis. Von Neumann's stability method is analyze the stability of any mathematical system This is also useful for applying to schemes, computational fluid dynamics schemes. Go to next one. Stability is the property of a dash. Okay. Stability is the property of a what? A partial differential equation, discretized equation, discretization process, or mathematical. Stability always a property of a always a equation, and more specifically it is discretized equations. Not a process, it's a equation. So it's a what? Stability is a property. Property means cannot be a process. Stability is the property of equation. PD partial differential equation or mathematical model. It's only a property of discretization. Okay. Let's go to the next one. For which of these problems error will be bounded if the system is stable? If you see the question, subsonic, supersonic, in-V-skid. Okay. Okay, error bounded. Error bounded means what? Error bounded is asking. It means that error is bounded when time in. Okay, this is the can be a full. In the question they are not intentionally not writing the full statement. But you will, if the time means obviously the answer will be. Whenever there will be error bounded thing will. Okay, you always remember error bounded when time increases. The full condition. Obviously, error is bounded and in time will increase. Usually, it can be a what? Transient problem. Whole idea. A stable system keeps the error bounded when time increases. One more thing you can write down. Stability guarantees that the method gives a bounded solution if the exact solution is bounded. The stability guarantees that if the method will give a bounded solution, but that solution is bounded, then only it gives you the guarantees that the okay the solution is rounded. Okay. Transient system is said to be stable if dash. Obviously, for stability can be solved in uh, actually the answer will be C. The system can be solved for cell and boundary condition. The system for the and boundary condition, then only we can tell the system is okay. If you see any kind of stable problem, the simulation we have to start. First, we have to see what is the initial condition. Then, to solve that problem, what are the given boundary conditions? Okay, if these two things are there with us, okay, we can tell that okay now the conditions the system is stable. Okay, for a particular conditions, the okay to make the system. Uh, telling D. Okay, D means second iterations are same. Uh, yeah, that's true. The error has to reduce with increasing time step. The error should reduce. That's absolutely correct. But it a necessary condition. Really, what stability means? Because you see, stability for this problem when solving the problem, absolutely correct. Who consider may or may not true. For example, okay, I see 10 seconds, then I then particular know that you have to run it possible. For example, person I different range 50 second position, whatever it is in the option. If you second it may or may not be true. I tell it same system. I run a for 11 computer. Then I found a slightly 5 Kelvin time step. What are that okay? Through the way the Sunday two concept. Absolutely. When the solution was, but these are not. For that depends upon the initial. For the same problem, I different types. Which for effort for the person is and find what is the sort of the but do it practically to instead of if option it is for the two consequent iteration. If you have finite iteration, finite or are the infinite step are same. Results are the finite time are same. This kind of or or, or at the n or n minus one, or where n is the like that some then option D truth. Okay, how I will agree that confused. So most probably the answer is what? This question is not that much difficult. It's very basic. I think for the whole you should know all these things very carefully. So we can go to the next one. Stability of a explicit transient scheme. What? It one another explicit. This I think already covered, but yeah, I will give you one. For this question, the answer will be stability of transient scheme vary from implicit and explicit scheme. Now stability the stability of the explicit scheme is limiting the what? Time step size. Now for implicit scheme, it is improved by under relaxing the. So this kind of question can become, or what is the explicit transient and implicit transient, all these things. What it's told is that okay, the explicit transient scheme is related to your what? Limiting the time step size. Okay, whatever the over relaxation is there, under relaxation is there, grid size is there. Okay, for the transient scheme, transient explicit scheme. Okay, transient means what? Transient means obviously time related one. Okay, so explicit and implicit means what? On scheme is there is two types of scheme available. One is explicit scheme and the implicit scheme. Implicit scheme can be solved using what? Iterations. Okay. Explicit one given equation is there. Okay, you have to solve that only governing one governing. That's not the idea of explicit and implicit scheme. Because here transient is came into existence. So usually transient means time is came into existence. Okay. For that, explicit transient scheme having what? Limiting the time step is the correct option. If in the option implicit transient scheme is there, obviously you have to go for under relaxation or over relaxation. Mostly we will do under relaxation factors. Okay, over relaxation the rare in means if you see in the study, relaxation is came into all this thing over, I think here the whole thing. So now next, which of the following is a sufficient condition for a system to be stable? Okay, actually in stability different types of questions can be asked. Okay, so this is what means. So I am just framing the question different types so that it will be your will be very much clear. So this is a very important criterion, that is Scarborg criterion. Okay, Scarborg. Okay, he given one criterion. Okay, we can see the condition. Okay, now here you find out what is the von Neumann stability analysis. Okay, so criterion when came into existence. Okay, so there obviously Scarborg criterion will the first one. Okay, type of analysis means von Neumann stability analysis. Starborg this C ups in this question you are asking, I think grid size, I think. Ability for explicit transients related to, no, it does not depends on, I think, grid size only, because you see in the question transient is mentioned na, obviously it depends on the what, only time step. Okay, grid is not that much important in this type of questions. Okay. They are intentionally giving this grid size to confuse you only, because when there is explicit scheme they are telling transient scheme, how we can directly go to grid. That's what the whole idea. There is a comparison, maybe explicit and implicit scheme. Tell me which type of scheme will need the more importance in grid size. Okay, so there you can write down, okay, okay, in implicit scheme we have the more importance of grid size. Okay, this type of question if they will frame, then I think grid size is important. Okay, so this question is straightforward. If you know the criterion, then only you can answer the question. Okay, Scarborg criterion. This is the end condition for a system to be stable. Gives a condition coefficient matrix. In the problem. Okay. So this Carver criterion can be asked in one more way type of that we can see now. Especially option if you know the Carver criterion. Okay. So the criterion is the coefficient matrix has larger values in the main diagonal. Okay. Again, coefficient matrix to be diagonally dominant. Okay, and the diagonal elements should be larger than the what? The non-diagonal elements. A system is said to be stable if what? Okay. Actually, this thing I think you already told. Okay. Does not magnify the errors occurring in the course of what? Solution. The error will be what? Error should be minimum. And go on error produced while the solving the problems. Stable means that does not go on increasing the errors produced while solving the problem. Solution should not diverge from the exact answer though errors are one. It is difficult to analyze the stability of gas. Okay. Always remember if it's always difficult to analyze the stability of a non-linear system. That's the first thing. If there will be there will obviously be a confusion. Most of the people will choose the A option. Okay, non-linear system without boundary condition. Obviously, if there will be boundary condition means obviously it is easy. Okay, and if it is without boundary condition means obviously it will be difficult. Okay. Non-linear system is obviously difficult to find out the what stability. Okay. It should be noted that if it is non-linear system and there will be without boundary condition, it's near impossible to find out the what stability. So that's the whole thing. Okay, so that's the reason this question is framed. So the non-linear system with boundary condition at least the difficult one. Okay, already it's the difficult one. If you don't give also boundary condition, then gone. This is possible to find out the solution. Okay. So that's for the whole. But if you see stability of the linear system, if it is a linear system, okay, boundary condition, without also boundary condition, it is also easy to find out the what stability. But a non-linear system with boundary condition itself is difficult to find out the what stability. Okay, and without boundary condition of non-linear system, it's impossible to find out the stability. Okay, the value of turbulent viscosity is fairly close to that of dash. Obviously, if you see the options, all are viscosity given. Okay, if you see, all are viscosity. Okay, so viscosity cannot be a option. Okay, can be a, okay. Obviously, you know very well turbulent diffusivity and turbulent viscosity are very close to each other, and how is it? We will see. The most more common term is what? Eddy mixing. Due to eddy mixing. Its viscosity the viscosity is the transport of momentum and transport of heat. Okay. Which of the following scientists introduced the turbulent velocity? The Boycinic, 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 the person what turbulent viscosity. Boycinic. At the turbulent stresses to the what main flow. Introduce the concept of eddy viscosity or what turbulent viscosity of the turbulent flow, and in this concept he will equate the turbulent stresses to the what main flow. Okay, thing done. Can see more of his work paper. Okay, so now let's go to the next question. The kinematic turbulent viscosity is what? Okay, okay, it's a okay. Uh, Turbulent length scale and velocity scale. So kinematic turbulent viscosity is the product of is proportional to the product of the Vt and the Lt, which is the turbulent velocity scale and the turbulent length scale. What is a dynamic turbulent viscosity? Okay, it is same as mu t is equal to T into. Dash relates the turbulent viscosity and the diffusivity. Obviously, this is by Reynolds. Okay, but here three options are Reynolds. Reynolds number, Reynolds analogy, Reynolds average, RNS. Okay, okay, Reynolds. Okay. If you see the viscosity and diffusivity, obviously Reynolds number. What is the Reynolds number? Obviously, okay, inertial force, viscous force. It relates to that. Okay, but here there is no viscosity and diffusivity. So Reynolds number cannot be option. Now Reynolds average theory. Trans is a kind of turbulent uh, transport model. Okay, under which different types of transport models are there, like K epsilon model, K omega model, okay, K omega SST model, okay, RNG K epsilon model, realizable K epsilon model, okay, many more models are there under RANS model. Okay, it does not depends on your turbulent viscosity and diffusivity, so this cannot be option. Ever average, obviously this is not a yes. Ever average mostly used for your what, finding the mixture fraction. Okay, reverse mixture fraction kind of thing. Okay, so this is not a option. Obviously now one option, the Reynolds analogy. Okay. Okay. transfer. Okay. How does it relates? Next one. Okay, which of the model solves the system of turbulent kinematic waves? Okay, so simple answer is Parlat and Almaraz model. Okay, so this Parlat and Almaraz solves the transport equation for the what turbulent kinematic viscosity, and this gives good turbulent boundary layer kind of problem. Obviously, when you are using Parlat and Almaraz model, you have to use in your boundary layer problem. Okay, in the boundary layer problem. Okay, let's go to the next one. The units of the kinematic and dynamic viscosity are what? It's very simple. D nu t here per second, mu t is here per second. Okay, So now next one, which are the not a turbulent viscosity model. Obviously DNS is not a turbulent viscosity. DNS, direct numerical simulation. This is a basic model to solve what? Turbulent flows. Means your stress transport. The KF7 model, the turbulent viscosity is given as what? There is B, okay, mu T proportional to K square by epsilon. Okay. So mu T proportional to K square by mu T is the turbulent viscosity, K is the turbulent kinetic energy, and epsilon is the turbulent dissipation. Okay. So this model is made from its parent model by turbulent viscosity. Okay, parent model which came into existence means there will be two similar options. Okay, KF7 model and is the parent model, and realizable KF7 model is the what? the derived one. Okay, so that's what the whole idea. So the answer will be what? Irrealizable K epsilon model. Okay, and what is told made different from its parent. Obviously, the irrealizable epsilon is different. Okay, in terms of what? Turbulent viscosity. In terms of so the epsilon model is the different from its parent epsilon model. It's in terms of what? New turbulent viscosity is formed, new transport equation for the distribution rate is what? Formed. Some other questions we can do. Hmm. Okay, let's try this one. Which of these the simplest types of sorry? Which of the equation is the starting point of the DNS method? Okay. The answer is B. Okay. Unity and momentum equation for incompressible turbulent. Next one. Yes, DNS can solve what? Can solve what? Transient 3D equations. Okay. Okay. The grid size and the time step size of a DNS method depends upon what? It is Reynolds number. Okay. When is the DNS method applied? Okay, or applicable? Okay, when you need what? Precise details. For which of the purpose DNS method is not suitable? For any kind of complicated design, this DNS method is not suitable because it will take lots of computational time. So then DNS method. Then DNS method is applicable for what type of problems? Okay, for simple geometry and Reynolds number problem. Okay. Which of these is simplest type of turbulent flow? Homogeneous and isotropic turbulence is the simplest way of turbulent flow. Okay. The Reynolds number for a 3D turbulent flow is 10 to the power 4. What is the number of grid points? Okay. So number of grid point 3D is na? Yeah. So Reynolds number in the okay. The Reynolds number of a 3D turbulent flow is 10 to the 4. What is the number of time steps needed? Okay. So Reynolds number for the turbulent flow, so 10 to the power 4. Hundred time steps. Okay. formula ret to the power ret to the power 1 by 2 number of times step. Which of these methods which are used for the time advanced discretization in DNS need more computation per time step? Okay, the answer is B, Rangaguta method. So this is what the much for attending the section. If you have any doubts, you can ask in my YouTube channel. Sumit Sagar Hota is my YouTube channel name. Okay, you can ask question in my YouTube channel in the comment section. If you have any other doubts related to your lectures, you can ask in the question and answer forum of NPTEL. Try to solve some similar kinds of questions. Okay, from the website I given earlier. Okay, and next section I think mostly also MCQ problems will be there. Okay, I think for the further ones we will have some problems. Okay, very much. Have a nice day. Right, we'll meet next week 6 to 8.